Alright, we are going to do an Artemis II replay. This is similar enough. I've got a lot of fuel drained out of it so that we don't make it too easy. Let's just go. Alright. We are just going to do a real nice and easy keep our thrust to weight ratio around 2, maybe a little more. We don't want to accelerate too fast and rub the atmosphere too hard. We'll constantly turn. Let's switch here to see our apoapsis. If there was an emergency, I could hit this and it would pop off. All the astronauts would live, which is lovely. Now I'm going to turn our throttle down where thrust to weight ratio is too high there. Dropping the solid rocket boosters. And now our thrust to weight ratio was way too low. I have to pick that up. And here we go. Gravity turn is in progress. Apoapsis is almost where we need it to be. Let's keep turning. Thrust to weight ratio is 3, a bit high, slow down. Keep turning, slow down. Alright, we're over 70 kilometers. We're going to make it into space for sure. We can slow down more and more. And I want to aim for around 100 kilometers. Let's go with 95 and cut it off. Alright. Now, we should be safe to deploy the shell in a moment. We're not seeing plasma, so let's just go ahead with it. And let's take our solar panels and deploy them. Let's pop off the nose rocket. Goodbye. And now we are a barely movable hunk of junk. We're going to wait until we get up near the apoapsis, and we're going to circularize. We're going to use a little more fuel than we brought so that we can dump our big tank into the ocean and start using our second stage. Alright. The burn's 25 seconds, so I'm going to fast forward to about 20 and start to align with our maneuver and hit it. That's going to be just fine. Let's turn on the lights. We're upside down just like we really would be. Alright, goodbye. First stage gone. We can try to hit this more precisely. A lot of times at the end of a burn you gotta aim up a little bit because you're starting to fall down. We're at a nice approximate circle. Now, here comes the fun part. Let's cancel that maneuver node, and we are going to go to the moon, and we're going to slingshot around it just like Artemis II did. We're also going to do some of the maneuvers that they did before that. So, let's plan our mission here. The idea is to burn weigh most of the fuel here to get part way to the moon, and then after that to burn more. So we're gonna do that, maybe with a little bit less fuel. We don't want to get too far out there, because then our period is too high and we won't necessarily get to burn at the right time. But we'll deal with that, because doing the precise slingshot is actually a little bit harder than even I thought. Now, so let's put this maneuver node here. Uh-oh. Okay. Let's do it like that. Okay, so now I'm going to see about this. Let's go focus view here. That is not what we want. That will send us right out of the system. So let's, okay, that's not what we want either. There we go. That's more like it. We want to get in front of the moon, and then we want to make sure we don't get launched out into oblivion. So let's just go with this for now. This is something we can work with. So let's fast forward to the next maneuver node. Now, normally this exact trajectory is not exactly what you would be hoping for when slingshotting around the moon and wanting to come back to Earth, or Kerbal in this case. And we will end up probably slowing ourselves down a little bit before we get there in order to slingshot around it properly and head back to the Kerbal planet. Alright, we've got a 30-second burn, so let's go. 15 seconds, start the burn, full power. Looks like everybody is safe and sound. There's Kerbal. Goodbye. And cut it off. Right there, okay. Alright, now we are in our large orbit, and what we're going to do is come around to here. And we are going to undock from our second stage. Now we can switch back and forth because I've got a computer autopilot in here. So we're fine there. Now this part would have probably taken a lot longer in real life, because maneuvers like this, you want to be very careful to not strike into anything too hard. We're going to set the target and move around and face it. Now, we just used the reaction wheels, but we want to actually test the RCS boosters, reaction control system. So we're going to turn off we are going to only use reaction control system now. Alright, so we're spinning. Let's stop. So we're going to pretend we want to dock with the Artemis probe here. So we are now moving towards the target. Now this would be too fast in real life. I believe they shoot for contact in the below 0.1 meters per second. Probably around 0.01 meters per second, although I need to double check that. Alright, so let's speed it up a little bit. Now we're a little off course here, so let's try to fix that. So it's easiest to know how you want to line yourself up if you're oriented a way that makes sense to you. So we can use the SAS to stabilize, and I can push to the side. I can point at the target again, turn on reaction control, slow down, slow down, slow down, slow down, go down, no, go up. See how I'm moving the yellow so that it lines up, because that is our actual motion. And now what we can do to kind of cheat the system is to aim ourselves at ourselves. And that would be a nice docking maneuver. Slow it down even more right before contact. And there we go. Contact. And let's turn off that SAS, because that is why it was jiggling there. Okay, lesson learned, lesson learned. Now, time to go. So now we want to deorbit this second stage. So to do that, we want to fly in the wrong direction. The retrograde direction. So let's go. The most efficient place to do it is at apoapsis. So let's add a maneuver and lower our periapsis to negative. Let's fast forward to that maneuver node. And here we are. We're still near the main ship. We're going to hit the gas and switch. So now our other ship is going to ram right into Kerbal, and we are good to move to our next maneuver node. And let's stop using RCS. There's no reason to. It's only when you need to turn very quickly, or if your reaction wheels are all maxed out. Forget the technical term, but they're already spinning as fast as they can. And my mouse is having some issues, so I can't really successfully turn the camera very well right now. Anyway, burn time is 20 seconds, so we are going to start our burn when there's 10 seconds left on the time to the node, which is now. This will get us to the moon. And I will focus on the moon to make sure that's where we end up. Alright, we'll just do a little more speed here. Just keep adding speed until we get where we want. We don't need the node anymore. Be about 200,000 meters or 200 kilometers away. It's a good distance. All right, here we go. So let's be on our way. There it is. We're heading there. We want to alter our trajectory so that after we go around the moon, we will be heading back to Kerbal, more or less. So, let's see what we can do. Okay, so we're going to try a slight adjustment here pretty early in the trajectory. It's trickier than I expected. The key is to not get too close to the moon, otherwise you're getting flung too far one way or another. And here we go. On our way. Here comes the moon, coming right for us. Now we're beyond the orbit, but we will get pulled back towards the moon. And here we are. We are getting pulled back now out of the orbit we would have been in into a new, slightly altered orbit, which will take us almost back to Kerbin's atmosphere, which is exactly what we want. I would have liked to have been a little closer to the moon, but this was what we got. My initial trajectory from circular orbit was probably a little bit off. I just eyeballed it, so I think launching a little bit earlier or aiming closer to the moon might have helped. It might be the other way around though. Stuff is quite tricky sometimes. So we can always try again later. But here, let's go to our periapsis. Get an eclipse of Kerbal. And then there it is popping out again. And so now we're just going to add a maneuver that, well, we can add it actually here. Oops. Add it. Alright, let's just warp until we're out of the moon's gravitational influence. And now we just have to lower our periapsis so that we will be entering the atmosphere. And we're going to lower it to around 30. We're going to go there. Oh, stop. Okay then. Emergency, emergency. Alright, we got a... My cat messed me up on this one. I'm blaming the cat, guys. I'm blaming the cat. Alright, we're gonna do a retrograde burn and try to save this. Luckily we brought a lot of extra fuel. And we are good to go. Let's get ourselves closer to the atmosphere. And because I have skipped up the atmosphere before, even though I'm sure at this periapsis we won't, it's never a bad idea to use your remaining fuel to slow down right before you enter. Unless you end up dying. So we're going to do that. I'm going to show you how to do that properly, which is align yourself and aim just a little up of your retrograde. Keep that periapsis about the same. Keep pointing up, up, up. Make sure it stays around 30. Eventually you won't be able to slow down anymore without tanking it. And that's when you want to just totally stop this. Now, I think that is enough. I'm going to turn sideways now. And we are going to jump to that. And we are going to then face retrograde. And I'm going to speed up. Now we're entering the atmosphere. Coming in right over the ocean. Fair enough. We can hit the ocean harder than we can the land without dying, so that's good. Got our drogue chute. Got our main parachutes. I could have set them up to deploy separately, but I'm impatient. We got Jeb, Bill, and Bob, of course. Now, if we want to go a little bit slower, we can jettison the heat shield. And now we're only going about 6.2. And I always do 4 times speed with no mods while parachuting, because it takes forever to land. But we're almost there. We did it. The astronauts made it home. Now you know how it went. Adios.